Welcome to The Explainer. Today, we're going to connect the dots between some basic climate science, the huge actions being taken by a nation of over 1 billion people, and the global policies that try to tie it all together.
So, let's start with something we all take for granted, our atmosphere. It does way more than just give us air to breathe. You can think of it as a planetary thermostat, and the difference it makes is, well, it's absolutely staggering. Just look at these numbers. If you took away our atmosphere, Earth's average temperature would plummet to a frigid -18 degrees Celsius. But with it, we get a much cozier, much more livable 15 degrees. That's a 33-degree swing, and it's all thanks to a completely natural process.
And that process is the greenhouse effect. It's actually a pretty simple idea, but it's incredibly powerful. Certain gases in our atmosphere act like a blanket, trapping some of the sun's heat and stopping it from just escaping back out into space. It's literally Earth's life-sustaining warming blanket.
Okay, so that leads to the obvious question, right? If this is all natural and, frankly, essential for life as we know it, what's the big deal? Well, the problem isn't the blanket itself. The problem is that human activity, especially since the Industrial Revolution, has been making that blanket dangerously thick.
Right, so this is where we get to the real heart of the issue. This thickening of the blanket leads to what scientists call the enhanced greenhouse effect. So, what exactly is making it thicker? What are these gases that are driving this change?
All right, let's meet the main players. You've got carbon dioxide, or CO2, mostly from burning fossil fuels. It's the big one, responsible for about 60% of the warming we're seeing. But then you also have methane, coming from things like livestock, and nitrous oxide, mainly from agriculture. And then there are these things called fluorinated gases from industrial uses, which are a whole other story.
And here's a really crucial point. A ton of methane is not the same as a ton of CO2. They are not created equal in their ability to trap heat. To actually compare them apples to apples, scientists use a special measurement. It's called global warming potential, or GWP.
We start with carbon dioxide. It's our baseline, our yardstick. So to keep things simple, it's given a global warming potential of exactly 1.
Now look at this, methane. Over a 100-year timescale, it is 25 times more potent at trapping heat than CO2. That means a much smaller amount can have a way bigger impact.
And if you thought that was a big jump, check out nitrous oxide. Its global warming potential is 310. It is over 300 times more effective at warming our atmosphere than the exact same amount of CO2. The numbers get pretty wild.
So with all that science in mind, how does a massive country with over 1 billion people and a booming economy even begin to address a challenge this huge? Well, let's dive into India's strategy.
The absolute centerpiece of India's approach is something called the National Action Plan on Climate Change, the NACC for short. And you've got to understand, this isn't just a single law. It's a massive, comprehensive framework that coordinates everything across tons of different parts of the economy.
And the way they've structured this is really interesting. The whole thing is built around 8 core missions. You got the stuff you'd expect, right? Solar energy, energy efficiency. But they also focus on really specific challenges, like protecting the Himalayan ecosystem and shoring up agriculture. It's a truly multi-pronged attack on the problem.
And what this all shows is that the plan's goals are incredibly broad. It's not just about cutting emissions, that's what we call mitigation. It's just as focused on adaptation, on building knowledge, and on conserving natural resources. It's a really holistic vision for the future.
Okay, so a big, ambitious plan is great, but what does it actually look like on the ground? How does this blueprint turn into real-world action? Let's get into the concrete targets.
One of the biggest headline-grabbing commitments is all about power. By the year 2030, India has pledged that a full 40% of its installed electric power capacity will come from non-fossil fuel sources. I mean, that is a massive energy transition.
And a goal that huge needs some serious muscle behind it. So you have these incredible specific targets. On one hand, the National Solar Mission is aiming for a whopping 100,000 megawatts of clean energy. And on the other side of the coin, the country's trying to create a massive new carbon sink by growing its forests, enough to absorb an extra 2.5 to 3 billion tons of CO2.
And you know, these big national goals don't just happen by magic. They're driven by these really practical, on-the-ground programs. You've got things like the PAT scheme, which gets big industries to be more energy efficient. You've got the Ujala program, which helped get millions of energy-saving LED bulbs into people's homes. And you've got incentives for electric vehicles and even a carbon tax on coal. Each one is a little piece of a very big puzzle.
Now, we have to pull the camera back for a second. It's so important to remember that these national efforts, as big as they don't happen in a vacuum. They are all part of a larger, evolving global framework trying to coordinate this action all around the world.
And you can really trace how the world's thinking on this has changed by looking at these key agreements. It really kicked off with the Kyoto Protocol back in '97, then there was a huge dramatic shift with the Paris Agreement in 2015, and then it got even more specific with agreements like Kigali, which targets those superpotent fluorinated gases we talked about.
And the fundamental approach to who's responsible has completely changed. Kyoto put legally binding targets only on developed nations. But the Paris Agreement, it totally flipped the script. It created a model where all countries, developed and developing, come to the table with their own national climate plans, with the shared goal of getting more ambitious over time.
So this leaves us with the final big question, doesn't it? We've seen the hard science of our warming planet, and we've seen the detailed blueprint one major nation is using to fight back. The ultimate challenge, the real nail-biter, is whether the sum of all these national blueprints from India and every other country will actually add up to the global action that the science tells us we desperately need. And that, right there, is the equation the entire world is trying to solve right now.